I'm going to demonstrate using the TomBio plugin for QGIS to display some data, biological records in an international geographical region rather than the UK. I got the data from this website here, cmap.m.duke.edu, and the data set that I'm going to work with is this one. This is the one I've downloaded. I've downloaded it as a CSV, and I can use that with the biological recording tool in QGIS. So here's QGIS with a map of the world, and I've got the coordinate reference system set to WGS84. I'm going to open the TomBio Biological Records tool up here. It appears docked over in the right hand side of the screen here. So I'm going to browse to the CSV file which I downloaded before. I've got that in this little folder down here. Here it is. So it's opened. I can see the records that have opened by looking at the top 10 in this tab here. So that's the kind of data that's coming through. I can see that they're georeferenced by latitude and longitude, WGS84. So in my data specification tab, I have to specify a grid reference column, that's particularly suitable for the UK context, or an X and a Y column where you've got easting and northings or lat longs. So I've got lat longs, so my X column is my longitude and my Y column is my latitude. I've also got a column in here which specifies the taxon, and that's this scientific name column here. I'm going to check this box so that it knows we're dealing with Latin binomials here. I have to set the coordinate reference system that these data are encoded in with this button here. So if I click that, I'll select WGS84, and the output CRS I will leave as the same as the input CRS, WGS84 in this case. And with that I'm ready to go. If I go to this taxa tab here, because I've specified taxon column, I can use this build tree button here, and this looks at all the taxa that I've got in the CSV. So if I just select all of those for a start with this check all button, and then use this button down here, I will instantly get a map of all the records in that data set. So let's zoom to the region where we've got most of them, which is around South America here. So there we go, there are all the records. And if I look at the attribute table for those, we'll see that basically we're seeing everything that's in the CSV file there. So that's one way of quickly creating a map. If I uncheck them all, I can pick particular species. So let's see, let's have a look in here. Let's pick this, make a species map for that, turn that one off. You can see now I've got a distribution map just for that species. So I can make individual distribution maps. Apart from mapping the individual points, I can also create grids and aggregate records by grid. And to do that with data that isn't encoded in a British National Grid system, I have to use this last option down here, User Defined Atlas Size. And here I'm going to specify an atlas size of, I will say, 2 degrees. And it's degrees because that's the coordinates reference system, the units of the coordinates reference system which we're using, WGS84. So if I select all of the records here to start with, all of the species rather, with this user-defined atlas size of 2 degrees and then create the map, I'll get them gridded up and summarised. And if I look at the attribute table for that gridded map here, you can see that it's got a number of columns on, including a number of records. Abundance in this case is the same as the number of records unless we specify an abundance column, and a richness. So we can actually see the species richness for each of these grid squares that we've created. We can colour up our map, of course, to illustrate those data. So if I say now in QGIS, this layer is going to be displayed with a graduated style based on the richness column, I'll change the colour range, or the colour palette to be yellow to red, and I'll take a natural breaks type classification and then just OK it, and then we see we've coloured up the grid square, the 2 degree grid square, to reflect the species richness for the cetaceans in this data set. We can change that size really easily, so say I wanted a 1 degree grid map instead, just change it there, create another layer, you see we get the 1 degree. We can colour that up in the same way using the basic QGIS styles. So you saw me doing it there for all species, but we could do this for individual species, as you saw me do for the individual species map up there. It's a really quick, flexible way of creating shape files from a CSV of biological records. These are temporary layers. If we want to save any of these to a permanent layer, we have to click them, right click, and save as a shapefile somewhere. That's it.